Okay, so hopefully you guys will be able to find me. I'm going to go ahead and post that. I messed up the live stream. Sorry, guys. If anyone's joining right now, I messed up the camera settings the first time. Hopefully you guys will be able to find me. Hey, Anna. I think everyone's still getting back and connected. I messed up the first time and I had the wrong camera set up. Okay, I'll give everyone one more minute and then I'm going to start the demonstrations. Hey, guys. One more minute and we'll get started. Today we got some gas law demonstrations. So we're gonna do some things with crushing cans. I got lots of things with balloons going on. Lots of cool things to see. Okay. So we'll get started. So our first experiment, I am going to be doing some things with changing pressure and the volume. So I have a balloon here, and I'm going to zoom in the camera just a little bit. Okay, so I have in here, I have a balloon. And that balloon's like not too big. And I have this larger container. Well, I also have set up a bike pump. And with that, I have one of the like tips on it that you can blow a like a basketball or something up. And I have a hot glue to the cap for this bottle. So what the purpose of this setup is that I can increase the pressure inside of this water bottle. Okay, so I got that everything on tight. And hopefully what's going to happen is that this balloon inside of it is going to shrink, okay, because one of the gas laws. Can you zoom in? That's a good point. Ooh. There we go. There's also some moisture in there, so it's getting kind of condensed. And you can see because of the pressure in the bottle, the bottom of it is actually like pushed its way out. But as I get the pressure, it's going to build and build and build. And that balloon inside of the water bottle is going to get smaller and smaller. I'm not going to make this one explode because that wouldn't be safe, but maybe something later. So this pressure is to the point where it's probably going to, it's the max point. So now I'm going to let the pressure release and the balloon should get bigger again. And so it gets big again. I know the video quality on that's not that great because of the kind of the sun and the moisture inside of that balloon, but pretty cool, right? So that is one of the gas laws. That is called, whoop, we'll fix that. Zoom back out. Oop, maybe a little bit down. Okay, so that's one of the gas laws called Boyle's law. And Boyle's law tells us the relationship between temperature and pressure. So we say that those laws are inversely proportional. So as one of those things increases, the other of those things goes down. They're inversely proportional. So as the pressure inside of the container increased, the volume of the balloon inside of it decreased. So as pressure goes up, volume goes down. So that's our first gas law experiment. 1 down, 6 to go, or 5 to go. Okay. Our next one is going to relate temperature and volume. Okay. Next one is going to relate temperature and volume. And for that, I have some containers of hot water and cold water. Hot water and cold water. Okay, so I got blue for blue for cold and red for hot. Okay, and I also have this balloon that's attached to a test tube. Okay, so we got a little water balloon here, and that's over the test tube. Now, the air, the gas inside of this test tube is going to increase when I put it in the hot water. So hopefully you'll be able to see the top part of it. I think we're good there. And you can see the balloon kind of like sticks up straight, right? Right here. It sticks up straight. And then when I put it in the cold water, I think if I do that, you can still see it pretty well. I'm going to put it in the cold water, it sinks back down. I'm going to put it back in the hot water, it goes back up. And put it in the cold water, it goes back down. Hot water up, cold water down. Boop. So that law is called Charles' law. And Charles' law tells us that temperature and volume are proportional. So as one of those two things increases, the other one decreases. So as the temperature increases, boop, the volume of the gas inside of the container, inside of the system, so the whole test tube and the balloon, the volume expands. And as the temperature decreases, the volume also decreases. So that's one that we have with temperature and volume. So that one, that gas law is called Charles' law. I also have one more demonstration to go with Charles' law. And for this, I'm going to leave the cold water here for us in a second. But in the meantime, I have here a water balloon, okay? And that water balloon is going to go just on top of our Erlenmeyer flask. So it's almost like a cap, okay? So it seals the system in. No more gas can escape. So when that happens, the volume inside of here is kind of fixed. So this is again going to relate temperature and pressure. And I am going to use some fire. Where did my lighter go?
It's right here.
Oh, cool. And I need, because I'm going to use fire for this one, at least while the fire is going, I am going to put my goggles on, right? I've got my piece of paper. Okay. We're going to light that on fire. And what I'm doing here is I'm just creating an environment inside of the test tube that's hot. And I blew it out. We'll get to work. You know what? Instead of that, I'm just going to put it in the hot water bath for a second. to kind of get that to be a little bit hotter. Hot water bath. Just heating it up a little bit. It's almost to the point where the glass is too hot for me to hold, but not quite so much at the top. Okay? So now that I've gotten that water or that glass kind of hot, I'm going to take this. And as it cools down, well, the volume is going to want to shrink, just like that balloon in the last one. Okay? So, I shouldn't have made both of these blue. Let's do this. We need this cold water soon anyway. Here we go. So as we do that, balloons being pulled down into that. Let me zoom in a little bit. Can you hold it down? Perfect. Go with that. I don't know if we can get it to go all the way down in there. Hopefully if I... Yeah, sometimes you can do this with eggs, and it will work, but I didn't want to have an egg, like, well, I didn't really have time to prep that, so. Okay. We'll let that guy sit there and see if it wants to sink into the container. We'll give it a little bit of time, but you can see it's definitely being pulled down into the container, right? So that's another example of Charles' law. As our temperature decreases, so does our volume. So our volume is the space inside of the container that's being sealed there. So maybe we can get it to pop all the way down in there. We'll see. I'll leave that be for right now. Okay? Well, actually, let's put this back here and see if it'll do its thing back here. Because I do need this right here, this bowl of water right here. You press the autofocus for me? If the zoom is good. Can you press the autofocus? Yeah. Perfect. So I got my niece Kendra helping me with camera today. For this one, we have a little bit of a crunch situation, so I am going to leave the lab goggles on, okay? Over here on my hot plate, so a little bit off camera, I have 3 cans of really hot water, okay? And so I am going to see if we can get this to crunch. If I flip this over, sometimes you can get the can to crunch. If not, I might have to turn the heat back on to see if it's gonna do this. But let's see. Ready? Nope, not hot enough. We'll try that one again in a second. It's gonna heat back up. We'll come back to that one in a second. Our next, clean up a little bit. You're doing it to crunch it before. We'll see if I can get that one to work. I got it to work right before this, but every time I've tried to do it for students in class, it never, ever works for me. Okay? So next, I have some balloons. I'm going to do a little bit of camera work here. Give me a second. Zoom back out. Okay. So we got, this is just your typical baking soda and vinegar experiment, right? And you guys have all seen baking soda and vinegar before. You know that you combine the baking soda and the vinegar, it makes lots of bubbles and It makes the volcano explode and stuff, right? Well, when you have a closed system, instead of that gas just bubbling up and fizzing out and going everywhere, you can capture that gas. And so I have inside of each of these a different amount of baking soda and a different amount of vinegar. And so I know about the ratio that makes the reaction happen the best. And so it's about 25 milliliters for every like 1.7, 1.8 grams of baking soda. And so I have those in different proportions. This one is just the original 25 milliliters of vinegar and 1.8 grams of baking soda. This one is 4 times that amount, and this one is 8 times that amount. And so hopefully, as we get more reaction to happen, we get more gas. Okay, so we'll see if we can get this to work. Woo! That one makes like a decent sized balloon. I don't feel like that one's gonna explode on me. These other two, well, let's just put the goggles on to be safe. We'll see. Okay. So I got that one going and that one going. Ah! So lots of gas, right? We got baby balloon, middle bear balloon, mama balloon, papa balloon, right? So we got lots of gas forming, right? Hopefully this doesn't bust on me. I think I used good enough balloons to where it's not going to bust on me. But what we see here is that as we create more gas, the volume increases, right? So this is a law called Avogadro's law. And Avogadro's law states that if you have more substance, the volume increases. And so Avogadro is a guy that did a lot of work in like chemical reactions and our understanding of chemistry. And so he actually has a number named after him. And 1 mole of a substance, and that's the amount that we measure things in chemistry, like the amount of substance. 1 mole of the substance is Avogadro's number worth of particles. So 1 mole of carbon dioxide, which is the gas that was produced here, is 6.022 times 10 to the 23rd power particles of carbon dioxide. And so we can kind of think about that in these molar ratios. But what we wanted to see here, and I think I'm okay to let go of them now, is that as we created more gas, it expanded the volume more and more. More gas, more volume. Okay, so that's called Avogadro's law. We have one more experiment that I want to do with Avogadro's law, but before we do that, I want to see if I can get our can crunch to happen. We'll put these off to the side over here. Okay, so we're back on this. Okay. I hear fizzling. I hear some fizzling over in my cans on my hot plate over here. So I think we're getting to the point where we're good. But I'm gonna go here, I'm gonna zoom in and see if we can get a good thing right here. Let's see. Try again. So this is a relationship between temperature and pressure. So we have 2 more opportunities. I have 2 more cans on the hot plate. We'll let that one keep going in case this doesn't work. But what happens here is I flip this over. Dang it. Guys, this never, ever works for me. Ever, ever, ever. Let's get some more ice. Let's try to make this colder. So now we have really cold water. Okay? So now we have really cold water, and I think it's almost boiling. So if it doesn't work this time, maybe I'll have to film it for you separately, but I can never, ever, ever get this to work. So fingers crossed. Okay, I hear it fizzling. We're gonna move it right to it. There, we got it! Look at that, guys. Crush the can. Can you adjust it up a little bit?
Should I zoom out?
No, that's good. So I got the Decanter Crush. So this is the relationship between temperature and pressure. We decrease the temperature really, really rapidly. And the pressure decrease also happened, right? Because temperature and pressure are proportional. As one decreases, the other decreases. So as that happened, the pressure decreased so rapidly that it like made the can implode on itself. And so that is an experiment that you might have seen. Some of our 7th grade science teachers do that experiment at Walnut Hills. So some of my students are on here. See you guys talking on the chat. And so we teach that when we teach pressure sometimes in the 7th grade. But that's the first time I've ever gotten to work with students watching. So exciting. Now, we have one more super important demonstration. I'm going to zoom back out. Whoop. Okay. Got my goggles and a balloon. So guys, this is also going to be Avogadro's. And what we're going to learn is that as, again, the amount increases, the volume also increases. And we'll see when the volume stops increasing. Oh my God, guys. I didn't know a balloon could get this big. I didn't know a balloon could get this big. Cover your eyes. Woo! So as amount increases, so does volume. And that's all you need to know about gases. So I'm not going to do a question and answer session today because we've already done 6 experiments. And I don't want this video to be too long to where people aren't going to watch it. Man, my ears are. Okay. But what I was thinking is that since we reached 200 subscribers, so cool, guys, 200 subscribers. What I was thinking is that I would do a question and answer video. So you can either comment below or send me an email, or you can give us a shout out on Twitter and ask our question. Our handle is @SullyTeachesSci, @Sully, SULLY, teaches TEACHES. SCI, Sully Teaches Sci, and I'll put that in the description as well. Comment below, send me a tweet with a question, or send me an email, a question about general science, and I will try to find an answer for you. I'll try to talk to an expert, figure it out, and we'll answer some of those questions in a 200 subscriber video. Just a reminder, if you haven't subscribed to my channel, make sure you like this video, if you subscribe in below, and go ahead and give me a comment if you have a question or if you just wanted to tell me that you like this video. So thanks, guys. I'll see you next week at Tuesday at 4 p.m. for some more Celly Teaches Science demonstrations. See you guys.